Sir, while we wait, would you be able to tell me a bit about the course, like the normal pace of the course when it's in person, like previous to the pandemic? Like, what's the layout, and is it like how long is it?
About masters or PhD.
So this program, this same program here, this training, I know that on a normal basis, it's usually in person in Thailand, right?
Yeah, in person Thailand. Actually, without COVID, if we think like that, so you may visit in Thailand and also visit different places, and you can see the physical structure of the power plant, different province, and each power plant they will present personally, and you can stay also maybe 1 or 2 days each place, something like that. Because of from Bangkok to our city, almost 1,000 kilometers. So it's not like that you come and back. Maybe so take 1 or 2 days.
Okay, I understand. Thank you. We're really missing out.
Yeah, we miss many things. Yeah. Okay, let's start. Sorry. Can you see my screen? Share
Yes.
screen. Okay. Good morning, everyone. My name is Shahriar Chaudhary. I'm lecturer at Faculty of Environmental Management, Prince of Songkhla University, Thailand. Today, I'm going to discuss about solar thermal and solar photovoltaic green rooftop. Earlier, I discussed about the solar PP and solar photovoltaic recycling. So before go to the solar thermal, I would like to invite you watching this video for why renewable energy, we are thinking about renewable energy and why renewable energy is most important for us currently. Let's see. Sound is okay?
Hello. Do you
Christine?
The song is okay, but
Yes, sir. Sounds
we're
okay.
able to only see it on the is there any way you can maximize the screen?
Okay. Okay.
We're seeing it in like a small box.
Okay, let's try.
Hello. Do you want to know how we can help clean the
We're still
planet of
able to
polluting
see
gases
it and
that
hear
go
it.
into the atmosphere? Control noise and reduce substances that pollute our rivers and streets. By making the commitment together to change our lifestyle for a more responsible one and using our intelligence to develop solutions that benefit the planet. In the energy generation process, for example, using resources such as water, wind, sun, and the heat from the ground. Although we can use non-renewable sources of energy for this purpose, such as coal and petroleum, they run out quickly. They are expensive, and they release some pollutants that cause global warming. Renewable energy is cleaner. It helps reduce global warming, and it can be used again and again. That is, it can be renewed at the same rate that it is consumed. Hydroelectric power. At the moment, water is the most efficient and most used renewable energy source in the world to generate electricity. When we use natural waterfalls or a river current, the force of the water moves a generator that produces electricity for everyone to use. In this process, water does not run out, it is not polluted, and after passing through the power plant, the river continues its natural cycle. There is another way of generating energy from seawater, using the tide and swell. However, we still do not have this technology in our country. The main source of power generation in Colombia and Isagen is hydroelectricity, as our country is privileged in water resources, as well as the power plants we already have. We are developing new projects with this technology. Geothermal energy. Captivating secrets are kept underground, such as geothermal energy. In the style of any science fiction novel, the Earth has areas where the heat warms underground water, generating concentrated steam that can make an electricity generator move. Geothermal energy is highly efficient and available. However, finding these special spots is not so easy. You have to drill and invest a lot of time in finding, with luck, an area suitable for geothermal energy generation. At Isagen, we are developing a geothermal plant in the Ruiz Volcanic Massif, located in the Caldas department. And we also have an agreement with Ecuador to explore the potential of the border area of both countries with the Tofino Chiles Cerro Negro plant. Wind power. And speaking of the wind, historical windmills have regained value over recent decades thanks to the development of wind energy. With the use of large structures, currents of air are used to move a generator that produces electricity. This energy is used a lot in Europe, the United States, and in some countries of Asia, while in Latin America it is just starting to be used. At Isagen, we are carrying out 2 projects, a wind farm in Guajira, and we are carrying out studies to identify the country's wind energy potential in the departments of Atlántico and Guajira. Solar energy. The sun is fire that sends us light and heat to maintain life. This resource is used to generate photovoltaic energy through special panels that harness solar radiation in a process in which photons or energy particles react to form a power circuit. The process is a little more complex, but solar energy has made the autonomous operation of many tools possible, and it is increasingly gaining ground in the world. Bioenergy. Other forms of renewable energy include bioenergy, which is the use of wood, vegetable oil, and agricultural waste to generate electricity. At Isagen, we are carrying out research for the production of biofuel. We are also researching other ways of using coal cleanly and efficiently, such as gasification, to produce cleaner energy and fuel. In this way, man uses nature and the technology he has developed to attend to his energy needs in better harmony with the planet. Thank you very much.
So what is a solar thermal energy? Solar thermal is a form of energy and a technology for harnessing solar energy to generate thermal energy or generate electricity. Is normally it's used for use in industry and also residential or commercial sector. So this is the
Solar thermal. The term solar thermal is used to describe a group of technologies that capture the heat energy from the sun and use it for various forms of heating and the production of electricity. For heating, solar thermal systems are referred to as passive or active. Passive systems are more basic and have no moving parts. They simply rely on design features to enhance our ability to capture and use the sun's rays, like a greenhouse or a solar oven. Active systems have mechanical components like fans or pumps to circulate heat-carrying fluids. These systems can be used for residential or commercial heating. For electricity production, high-temperature solar thermal systems called concentrated solar power, or CSP, use groups of mirrors to concentrate solar energy on a central collector. This produces temperatures high enough to generate steam, which then turns a turbine, driving a generator to produce electricity. CSPs are primarily found in desert locations where space and sunlight are abundant. One advantage of solar thermal energy production is that it is a clean and renewable energy source that uses a free form of fuel, the sun. Most solar thermal systems are also low maintenance because they use simple technologies and in the case of passive systems have no moving parts. However, the nature of sunlight can cause problems for the use of solar thermal systems. Sunshine is not a very concentrated energy source, so it can take a large area to make a reasonable amount of energy, evoking efficiency and in some cases land use concerns. Sunshine is also intermittent, and its availability is dependent on location and time. CSP has additional advantages and disadvantages. The technology's ability to produce large-scale generation is an advantage for regions that utilize centralized electricity distribution systems. In the past, this was an advantage over solar PV systems. However, innovations in PV technology are challenging this notion. A key disadvantage to CSP is that installations are normally located in remote desert areas. Given that steam turbines are required to produce electricity, water access and evaporation are concerns for the viability of the technology. In addition, transmission of electricity over long distances is expensive and can lead to distribution losses. Finally, practical challenges such as upfront capital costs and awareness can also be barriers to implementation of all forms of solar thermal technologies. That's solar thermal. Solar thermal.
The history of solar thermal, Augustine Mochit demonstrate first time he show one exhibition, 1878, first time in Paris. And the first installation of solar thermal energy occupied in the Sahara, approximately 19th century, beginning of 19th century, like 1910, by Frank Schumann, when steam engine was run on steam produced by sunlight. Solar thermal is a more space efficient than solar photovoltaic. They can be up to 70% more efficient in collecting heat from sun ray than solar photovoltaic. This is the working principle of solar thermal. We can see that solar thermal plants, this is the tracking solar glass. It's reflect and absorb this tank, take heat from this this glass solar tracking reflector, and we can say that solar thermal power plant use the sun ray to heat a fluid to high temperature. In this tank, use fluid to heat, absorb heat, and it become a hot temperature, like a high pressure. And the fluid is calculated through pipes so that it can transfer it heat to water and produce steam. The steam converted into mechanical energy in a turbine, which power a generator to produce electricity. This is the turbine. When the fluid heat a certain level, then it flow, and it help to run turbine, and then generator open and then produce electricity. So it's like one kind of replace of coal power plant. We can replace here by sunlight, like steam. The solar thermal system, there are a high pressure liquid storage tank used along with the solar thermal system to allow blank serve several hours of potential electricity. There are three kind of solar storage tank, like two tank direct system, two tank indirect system, and single tank thermoline system. Two tank direct system is a two tank direct system is solar thermal energy is the system stored in the same fluid to use to collect it. The fluid stored in two tank, one tank in high temperature and other at low temperature. Fluid low temperature tank flow through the solar collector or receiver, and where solar energy heat it to a high temperature, and it then flow to the high temperature tank for storage. Fluid from the high temperature tank flow through a heat exchanger where it generates steam for electricity production. The fluid exits the heat exchanger at a low temperature and return to the low temperature tank. Direct storage was used in earlier parabolic throw power plant. We use it parabolic throw power plant. Two tank indirect system function is the same way as the two tank direct system. Is expect different fluid are used in the heat transfer and storage fluids. This system is used in a plant in which is heat transfer fluid is too expensive or suited for use as a storage fluid. The storage fluid from the low temperature tank flow through an extra heat exchanger where it heated by the high temperature heat transfer fluid. The high temperature storage fluid then flow back to the high temperature storage tank. The fluid exits this heat exchanger at a low temperature and return to the solar collector or receiver, and where it is heated back to a high temperature. Storage fluid from the high temperature tank used generate steam in the same manner to the two tank direct system, and extra heat exchanger which add the cost to the system. The system also use parabolic power plant such as Spain or Morocco. They use that technology. Single tank thermosilane system at any time during the operation portion of the medium is a high temperature and portion at a low temperature. That means one tank, but upside they use high temperature medium, and lower side they use low temperature medium. The hot and cold temperature region are separated by the temperature gradient or thermosilane. High temperature heat transfer fluid flow into the top of the thermosilane and exits the bottom of the low temperature. This process moves in the thermosilane downward at the thermal energy of the system storage. Reversing the flow move the thermosilane upward and remove the thermal energy from the system and generate steam, and then that can help to run the generator and produce electricity. Buoyancy effect create a thermal satisfaction of the fluid within the tank, which help stabilize and maintain the thermocycline. The using of solid storage medium and only need one tank reduce the cost the system and relative if we compare with the two tank system. And the system was demonstrated at the solar power tower. The system is this technology used for solar tower power. The types of solar thermal power plant, there are there are four kind of solar thermal power plant. We can see that parabolic throat system, solar power tower system, and solar disk. So these three technology actually available. This technology, compact linear frontal reflector, this one also available, but this three technology for especially for power plant. And we can see that there are several types of, earlier I mentioned it, like the linear frontal constant, a long row of flat or slightly curved mirror, the move independently on the one axis. The mirror reflect sun to the flagged linear receivers mounted above them or on towers, and tower based power plant like involve an array or helistrate large mirror or two axis tracking that concentrate the sunlight onto the fixed receiver at the top of the tower. And this is a high efficient imaging technology in which paraboloidal disk with two axis tracking focus on the sunlight to the point receiver. And this is the parabolic thought system. Parabolic thought system consists of the linear parabolic reflector that concentrate high onto a receiver positioned along the reflectors and focal line. The receiver is a tube positioned directly above the middle of the parabolic mirror and fill it with a working fluid. The reflector flow the sun during the daylight hour by tracking along single axis. The working fluid melted salt. Working fluid as a working fluid may use a melted salt, and the temperature 150 to 350 degree, and as it flow through the receiver and is then used heat source for the power generator system. This is the example of parabolic power plant. So we can see this video. This is the tower system, solar thermal tower system. The tower also central tower power plant. It's like this design capture and focus. This capture and focus on the sun thermal energy with the thousands of solar tracking mirror in roughly a 2 square mile field. The tower rides in the center of the heliostrate field. The heliostrate focus on concentrate sunlight on a receiver which site on top of the tower. With the receiver, the concentrate sunlight heat molten salt to over 1000 Fahrenheit, and 500 is approximate to 538 degrees centigrade. The heated molten salt then flow into the thermal storage tank where it stored and maintain 98% thermal efficiency, and eventually pump it to the steam generator. The steam drives a standard turbine to generate electricity. This is the solar tower plant.
Energy sustains human development as global energy transformation goes deeper. Concentrated solar power as a new type of renewable energy featured with thermal storage will be an irreplaceable player in the course of high-quality development of energy. Dalingha boasts plentiful solar resources and enjoys average annual sunshine duration exceeding 3,500 hours. Dalingha 50 megawatt tower CSP plant, invested, designed, and constructed by Subcon Solar, is one of China's CSP demonstration projects and entitled as National Strategic and Emerging Industry Key Project. When the sun rises, heliostats start to rotate and turn and track the sun in real time, accurately reflecting the sunlight to central receiver atop the tower. Molten salt is heated above 560 degrees centigrade inside the receiver and stored in a hot salt tank. The hot molten salt is then used to exchange heat with water, generating high-temperature, high-pressure steam that drives turbines for power generation. The plant is configured with a 7-hour molten salt thermal storage system, enabling continuous, stable, and high-quality power generation. In March 2017, construction of the project started in the Gobi Desert at an altitude of 3,017 meters. The oxygen level is just 70% of that on China's plain areas, and temperature can drop as low as minus 37 degrees centigrade. The harsh winter conditions suspended the construction for as long as 4 months. In November 2018, all installation works completed. On December 26, 2018, the steam turbine rotated. On December 30th, 2018, the plant was synchronized to the grid, becoming the world's highest tower CSP plant. The plant was built in a record time of 18 months, which is remarkable in worldwide CSP projects. The plant reached full load operation on April 17, 2019. After short trail operation, the final performance test kicked off in October 2019. Since then, the plant has been running stably, with all major indicators outperforming design parameters. The average generation fulfillment rate achieved 97.06% in the first half year of the performance test period, and in particular, the first quarter of 2020 saw a consecutive fulfillment rate over 100%, which was the top performance among its peers on the same stage. The rapid growth of power generation and fulfillment rate of the plant benefit from the optimization and management of Subcon Solar in engineering optimization, equipment selection, construction management, and operation strategy. Built on best practices from the Dalingha 10 megawatt project, Subcon Solar has improved overall system efficiency by coordinating the configurations of solar collector system, thermal energy storage system, steam generation system, and steam turbine system. Subcon Solar has independently developed a series of customized systems to improve automation level and optimize operation strategy. In return, the operation performance of the plant is further enhanced. With its impressive operation performance, Subcon Solar Delingha 50 Megawatt Tower CSP plant has become China's CSP success story, exemplifying the country's strengths in CSP technology, equipment, engineering, and operation. Subcon Solar will focus on CSP industry, enrich experience from practice, and explore state-of-the-art technologies of CSP, and provide more stable and efficient clean energy for human society with more advanced and cost-effective solutions.
This is the solar dish engine system. As a reflector, we use this reflector. Like the system consists of a stand-alone parabolic reflector that concentrate light onto the receiver positioned at the reflector focal point. The working fluid in the receiver is heated 250 degree to 700 degrees centigrade. Then use the Stirling engine to generate power. And parabolic dish system have a highest efficient of all solar technology, provided solar to electricity efficiency between 31 to 32%. And this is the dish, solar dish engine system power plant example.
Bright sunlight, fresh air, clean water used to belong to everyone on the earth. However, the water is no longer clean due to hundreds of thousands of tons of sewage discharge. The cities are engulfed by the smog composed of perennial emission of exhaust gas from the factories and automobiles. The global glasshouse effect is worsened by the excessive dioxide emission coming from the combustion of petrol and coal. We are gradually concerned by the alarming danger step by step. Nevertheless, we can change the situation and rebuild our healthy and beautiful home if we have the green dew energy. Established in Dalian in the year of 2011, and the head office now located in Zhangjiagang, a new industrial port city in the junction of Coastal and Yangtze River's Economic Development Zone. GOE is a high-tech company specializing in the development, manufacture, sales, and applied demonstration of Stirling solar thermal power system, and also in power plant construction, power plant commission. GOE has already set up demo projects in 3 cities globally with its leading research and development and production abilities. In Erdos, the 100 kilowatt dish solar Stirling solar thermal power demo park established by GOE has been put into use with annual power generation of 200,000 to 250,000 kilowatt hour. In Zhangjiagang, 25 kilovoltage dish and Towers Stirling solar thermal power demo park established by GOE has been put into use with annual power generation of 80,000 to 100,000 kilowatt hour. In Sevilla, Spain, GOE's 10 kilowatt Stirling solar thermal power demo park has been put into use. From China to the world, GOE will keep creating green, high-efficient and renewable energy for the world. With present annual production capacity of 10,000 Stirling engines, GOE has identified itself as the first-class company in the world to make industrial manufacture of the Stirling engines into reality from the groundbreaking of Stirling engine industrial base with annual production capacity of 100,000 units. Focusing on lean production and possessing the first automated assembly line of Stirling engine in the world to realize the assembly automation and intelligentization. GOE strictly controls every technical detail from raw material to finished product. Each product is delivered flawlessly to the customer with high precision applied to the original technical data of and a compatible level between the spares, which can be guaranteed to run safely and efficiently with easy maintenance within the life cycle. Thus, forms a better after-sales services system. GOE keeps creating value for the shareholders led by the management philosophy of scientific management, leading technologies, innovational development, and cooperation-based mutual benefit. GOE forms a set of integrative operation procedures from marketing, research and development, production to customer services to become the most reliable value-creating partner for the customers. Holding the idea of early intervention, GOE provides the optimized overall solutions for the customers from the beginning phase of design. Cherishing innovation spirit, GOE's new energy research and development team comprises the industrial elites from all over the world, including Mr. Slauson, Jerry, and Ken, the world top thermal power experts, and Carl, the electric automation expert, to consistently explore new technologies, new products, and new energies. At present, the products developed and produced by GOE include 25 kW Stirling solar power generation equipment, 25 kW Stirling combustive gas power generation equipment, dish solar collector tracking system, tower heliostat system, and bi-axis photovoltaic tracking system. Currently, the company has more than 80 patents with entitlement of National High-Tech Enterprise. Compared with traditional interior combustion engine, the Stirling engine, independently developed and produced by GOE, has leading advantages. No specific requirement to combustion source, suitable for all kinds of thermal sources. Small volume, lightweight, low noise, long lifetime, high combustion efficiency, and easy maintenance, etc. GOE combines dish solar collector tracking system with solar Stirling engine to provide the latter highly concentrated sunlight as the heat source to drive the power generator. Thus, forms the dish solar Stirling power system, which can be used in a large-scale solar thermal power plant, in oil fields, remote mountain villages, islands, short of or no power supply, and pasturing areas to set up distributed power plants. For independent of and on-grid power supply of one building for one household mode. The Stirling combustive gas power generation system, developed and produced by GOE, with utmost protection for the equipment from corrosion, highest efficiency and lowest power consumption, can replace the interior combustion engine used in the large drilling platform, can realizing resource recycling by making use of exhaust gas and coal cinder from the steel furnace to heat up Stirling engine for power generation, can make higher energy availability by burning compressed straws to heat up Stirling engine for power generation, can make use of biogas as combustion source to heat up Stirling engine for power generation, can also be used in hybrid power vehicles as the power source for green drive and low carbon life, can be used as high-efficient refrigerating machine by reverse running and commonly applied in central and household air conditioners, which becomes a great challenge to the traditional refrigerating machine and air conditioner. The dish clutter tracking technology developed by GOE can be combined with gas turbine to compose dish Brayton solar thermal power generation equipment, can be combined with thermoacoustic engine to compose dish solar thermoacoustic engine power generation equipment, can be combined with desalination hydrogen production devices for the use of desalination for and hydrogen production from seawater, and also be used in providing green solutions for municipal heating supply. The collecting, heat storage and heat usage technologies and solar heating and heating supply systems developed by GOE will alleviate and settle the problem of air pollution and smog in the cities to a great extent. By utilizing solar resource, it can be realized for 24-hour consecutive heating supply and industrial gas supply, co-production of heating, power and cooling, as well as the centralized scale production of solar power, which can resolve the problem of land loss in municipal CBD areas. Thus, made solar power used to commercialization stage for commercialized production, centralized transportation, and use in different places of the solar products by providing green, economic, and clean technical solutions. The single-axis and bi-axis solar tracking technologies can be applied in the heliostat system of tower thermal power generation, and also can be used in concentrating photovoltaic and ordinary photovoltaic tracking for sunlight to raise the viability rate of ground vegetation and protect ecological environment by increasing sunlight collecting performance. In the last few years, GOE has made out its proprietary intellectual power systems of dish and trough molten salt system, dish and tower molten salt system, and dish and gas, etc. by consistently exploring new technologies and techniques and combining most advanced trough and tower heat storage technologies. The power system can realize 24-hour consecutive and load-adjustable power generation, which technically solves the problem of replacing fossil energy with renewable energy by the end of this century in our country. Looking to the future, GOE keeps making technology innovation with international influence in the field of thermal power and becomes the leading company with core technologies for product design, spare production and intellectual control, and will move on with its objective of becoming the most competitive international public enterprise in the world. Innovate for excellence and cooperate with faith, sticking to the enterprise spirit of collectivity, practicality, excellence, and innovation. GOE will take the working staff as the most valuable treasure of the enterprise and consistently perform as the platform for the staff to create a value of.
This is the current scenario of a solar thermal station. We can see that Morocco is the highest position. They have the world largest solar thermal power plant in Morocco, 520 megawatt, and in USA 392 megawatt, and USA also have other more five or six more power station, thermal power station, and Spain 200 megawatt, but they have also 150 something more of 5 or 6, and India has a 120 megawatt power plant, and we can see that the Palestine territories they have 121 megawatt, and also Kuwait they have the 50 megawatt power plant. China not only one, China 10 almost 10 power plant, 100 they are separately, they are 10 power plant. This is the scenario of future solar thermal plan, like under construction, green one under construction, and yellow one proposed. And UAE, United Arab Emirates, they will under construction one power plant, it 700 megawatt. In China, 400 megawatt, and in Morocco, 430 megawatt. That all under construction. And Chile, they already proposed 1,100 megawatt solar thermal plant. And South Africa also, they already proposed solar thermal power plant. Kuwait, and at the same time, I can see also we can see also the in China they produce more. They proposed more 364 megawatt power plant, and Spain 50 and Kuwait 65. So this is the world largest solar power, solar thermal plant in Morocco. So we can watch this video.
Africa, and in particular North Africa, has tremendous potential for solar generation. Imagine a solar plant the size of 3,500 football pitches. Well, this is no fiction, it is reality. This is Morocco, the home of the largest concentrated solar plant in the world, the NOAA Solar Power Station. The solar plant sits on over 6,000 acres of land near the town of Ouarzazate. The project was developed in 4 phases. 3 phases with a capacity of 510 megawatts are complete and already functional. The 4th phase with a capacity of 70 megawatts is in development, and it will bring up the total capacity to 580 megawatts. This will be enough to supply clean energy to about 6% of the country. The NOAA plant will not be entirely a concentrated solar power plant. The first 3 phases are concentrated, and the 4th phase, which is under development, will use photovoltaic solar panels. So, how does concentrated solar power plant produce energy? Let's hear it from an expert.
Okay, take the natural heat from the sun, reflect it against a mirror, focus all of that heat on one area, send it through a power system, and you've got a renewable way of making electricity. It's called concentrating solar power, or CSP. Now, there are many types of CSP technologies: towers, dishes, linear mirrors, and troughs. Okay, have a look at this parabolic trough system. Parabolic troughs are large mirrors shaped like a giant U. These troughs are connected together in long lines and will track the sun throughout the day. When the sun's heat is reflected off the mirror, the curved shape sends most of that reflected heat onto a receiver. The receiver tube is filled with a fluid. It could be oil, molten salt, something that holds the heat well. Basically, this super hot liquid heats water in this thing called a heat exchanger, and the water turns to steam. Now the steam is sent off to a turbine, and from there, it's business as usual inside a power plant. A steam turbine spins a generator, and the generator makes electricity. Once the fluid transfers its heat, it's recycled and used over and over. And the steam is also cooled, condensed, and recycled again and again. One big advantage of these trough systems is that the heated fluid can be stored and used later to keep making electricity when the sun isn't shining.
Here we are in the solar field of the Noor Ouarzazate 3 project. It's a CSP, concentration solar power technology. We are in the middle of a solar field of 7,400 mirrors. As you can see, the size is quite huge. Each one of them is almost the size of a tennis court, and they all concentrate the solar heat. At the top of the tower that you see there, there's a receiver at the top of the tower, and all this energy boils a liquid that is salt, a molten salt. This heat is used to produce steam by boiling water, and the steam is basically driving a turbine to produce electricity. And this electricity is exported to the national grid.
Morocco has an ambitious plan to have 52% of its energy needs from renewable sources by 2030. The Noah plant is a giant step towards achieving that goal. It is important for other African countries to observe, take notes, and be inspired.
Hello.
Hello, sir. We're here.
Thank you. So, solar thermal market in Europe during the pandemic, like 21st to 2025 in future also. The data from a report of IEA, the solar thermal market in Europe is expected to post on year over year growth rate in of 1.3%. Based on the technology, and the low and medium temperature segment saw maximum growth in 2020. The low and medium temperature segment primarily include the small and medium scale solar water heating system for residential and commercial building. The segment is facing uh, severe competition from the photovoltaic system and the heat pump. The growth of market segment will be significant during the forecast period. Regional analysis, 91% of growth will originate from the Spain region. Maximum solar thermal power plant in Europe, in Spain. The decrease in the rise of concentrate solar power with the thermal energy storage will be facilitated. The solar thermal market growth in Spain over the forecast period. The market growth in Spain will be slower than the growth of market in rest of the Europe. Mark, please. The solar thermal market in Europe size is expected accelerate. We can see from the graph, accelerate at a CAGR of 2% during the forecast period. The solar thermal market, Europe in segmentally by the technology, low, medium, and earlier I discussed about that. And the market is fragmented due to the presence of many established vendor holding and a significant market share. And we can see also Germany, they increase 25.8%, and Brazil in Africa, America, Brazil, Cyprus, and Netherlands, Turkey, Portugal. We can see that they also increase their solar thermal process. This is the scenario of heating and cooling, solar thermal heating and cooling based on the industry and district heating, swimming pool, solar heating, solar air heating, and or solar cooling, hybrid system of heat and electricity. And we can see that solar district heating like photovoltaic. Germany is the first, and second Denmark, and third China. At the same time, solar industrial heat, in addition, by in 2020, China is the first position for industrial. They use for solar energy production product, and second Mexico, and third Germany. And solar pooling heating system, we can see that USA, Brazil, and Australia, they are using. In addition, hybrid system for heat and electricity, you can see that France first position and China is a third position. We know that solar photovoltaic system, we know the solar thermal, and another thing, solar application, also cooling system now available. And for refrigerator, we use this technology. Solar cooling system is that converted heat from the sun into cooling that can be used for refrigeration or air condition. A solar cooling system collect a solar power and use it in a thermally direct cooling process, which is a turn used to decrease and control the temperature for purpose like generating chilled water or conditioning air for a building. There are many different cooling cycle technique using various different principles to function. And the most common and popular technique included absorption cycle, the discrete cycle, and solar mechanical cycle. This is the absorption cooling process for a specific major component, an absorber, a generator, and also a condenser and evaporator. The evaporator is an essentially the refrigerator or air condition plant used in all cooling system, since it is where the cooling occur. The absorber hold an absorbent refrigerant mixer that is diverted to the generator and through a liquid pump. The generator takes the absorbent refrigerant mixer and heat is up using external solar energy that has been collected through to a source such as a solar panel or solar thermal system. The solution started to boil in deflection to the heat, turning water into a vapor, which flow to the condenser. The condenser liquid the water vapor, rejecting heat in the process, which is collected by the heat sink. The new liquid condensate is then directed toward evaporator through an expansion bulb. Finally, evaporation of the refrigerant at a low pressure causes to evaporator to absorb the heat from the cooled space, creating the cooling effect. At the end, vaporized refrigerant turn to the absorber and the cycle repeat. Solar power responds for driving this cycle. So then that can help to be a cooling system. This cooling system rely on cycling and dehumidification and humidification process. It used to be substance and materials that readily attract water from their surrounding for the dehumidification. These materials are known as descent are regenerated to the cycle by applying solar power. Third one is solar mechanical cycle. That the solar mechanical cycle works very different from the absorption and others one. Instead of creating the entirely a new system, solar mechanical cycle attempt to the combined solar powered machine with conventional cooling system. In this case, solar power is used to fuel the actual engine that produce the energy used to be operate the intercooling system instead of fueling the absorption chiller, like it does both absorption. This is the working principle of solar cooling.
Welcome to Academic Gain Tutorials. In this video, we will learn about vapor absorption refrigeration system, along with its different parts and functions. So, let's get into the topic. We know that refrigeration is the process of lowering the temperature by removing unwanted heat from a selected object, substance, or unenclosed space and transferring this heat to another object, substance, or space. The vapor absorption refrigeration system we are discussing today uses the ammonia water system for the refrigeration process. And it also needs solar energy in the refrigeration process. So, this vapor absorption refrigeration system can be also termed as an ammonia water cooling system. We can even call it a solar cooling system. Now, let's look into the major parts and components and basic working procedure of vapor absorption refrigeration system with the help of solar energy. First of all, here we have an absorber. Inside this absorber, we have a solution of ammonia and water. And, beside this absorber, there is a pump. Now, when solar energy is supplied to the system and the generator, then this pump starts working. Then using this pump, we will pump this solution of ammonia and water from this absorber to this generator. So, the function of this pump is to transfer the solution from the absorber to the generator which is running on solar power. Now, when the solution of ammonia and water reaches the generator, here, heat is produced inside the generator using the solar energy supplied to it. And, when heat is applied to this solution, both ammonia and water from this ammonia water solution turns into vapor inside this generator. We also have an analyzer inside this generator. When this vapor of ammonia and water is passed through this analyzer, the analyzer sends the water vapor back to this generator, and it only lets the ammonia vapor to pass through. Then from this generator, the residue of water vapor accumulated here will be passed back to the absorber again through this connecting pipe. Now, even after passing through the analyzer, there will be some proportion of water vapor mixed with this ammonia vapor. So, here we have a rectifier. This rectifier can also be called a separator, because it separates the rest of the limited amount of water vapor present inside this ammonia vapor through the exchange of heat. So, through the exchange of heat, this rectifier will convert the water vapor into liquid form, and separate it from ammonia vapor. Then, this separated liquid water is passed back to the generator. From there it will ultimately reach the absorber. Now, after separating the water vapor, here we have obtained pure ammonia vapor. But actually this is not a 100% vapor state of ammonia, because when heat exchange occurred inside the rectifier, the ammonia vapor has also converted into partial liquid ammonia. So, this pure ammonia in the partial liquid form will leave the rectifier and enter the condenser through this connecting pipe. Here, we have a condenser. When high temperature high pressure partial liquid ammonia vapor enters this cold condenser, then the condenser absorbs the heat from the partial liquid ammonia vapor, and completely converts it into liquid. This condenser can be water-cooled or cooled by any other substance from an external source, which will liberate the latent heat of this vapor coming into the condenser, and thus condensing keeps happening. Now, here we have an expansion valve. After condensation, liquid ammonia will leave the condenser and pass through this expansion valve. Now, this high-pressure liquid ammonia, coming from the condenser, will be expanded inside this expansion valve. We know that when expansion occurs, the pressure between the molecules decreases considerably, thus the temperature falls. So, this high-pressure liquid ammonia will be expanded into low-pressure, low-temperature liquid ammonia. Thus, here we get very cold, chilled, low-temperature liquid ammonia coming out of the expansion valve. Then, this liquid ammonia will be passed over to the evaporator. We all know that the main cooling effect or refrigeration effect always occurs in the evaporator. So, when this low pressure, very cold, chilled, Low temperature liquid ammonia will enter the evaporator coils. It will absorb all the heat present in the surface of the evaporator coils. By absorbing all the heat from the surrounding surface of the evaporator coils, this cold chilled liquid ammonia will turn into low pressure ammonia vapor inside these coils, and the surrounding surface of the evaporator will become cold by losing the heat to this liquid. Thus the cooling effect or refrigeration effect has occurred in the evaporator. After that, this low pressure ammonia vapor will leave the evaporator and enter the absorber again through this connecting pipe. Then again, this low pressure ammonia vapor will form a solution with the water present in the absorber. The pump will again send this solution to the generator, where the heat generated by solar energy will again form ammonia vapor and water vapor. Then again water vapor is sent back to the absorber. Ammonia vapor passes through the analyzer to the rectifier, and the whole cycle keeps happening over and over again. And thus refrigeration occurs continuously in the evaporator, and the surrounding space keeps cooling continuously. So, this is how a solar vapor absorption refrigeration system works, where solar energy is used to obtain the cooling effect. Thank you for watching this video. If this video was helpful, subscribe to my channel Academic Gain Tutorial. Welcome to
This is the advantage of solar thermal. Solar thermal energy is both renewable and sustainable, as it will never run out and help environment. It does causes it doesn't have any pollution, and it reduce from the bill, and also reduce fossil fuel dependency. Can be combined with the solar photovoltaic, and make it in future it make it cheaper. But there is some disadvantage also. Solar thermal energy, the energy initial cost of purchasing of solar system is fairly high, and it depend, although solar energy can still collect during cloudy and rainy days, not efficient, and we may not use some country they cannot use because it's need um, huge space for establish the solar thermal plant, and also the radiation, because depends on the solar radiation. Those area doesn't have too much radiation, so it may not convenient for or economical friendly for that area. And some of ecological or cultural issue. But in future, the major challenge now in installation and cost of energy storage, and because we know that we just receive daytime, but nighttime, so we need to store the energy, and the cost still fair high if we compare with fossil fuel, and the hot water storage production often sketch to their limit, and there are other also limitation. But we believe that in future we can develop the technology, and we in future technology can help us to, we know that because of every energy resource or renewable energy has some sort of disadvantage or challenge, but we can face it in future. This is the solar dryer. Solar dryer, we can use the sunlight for drying system like food. So solar dryer can be utilized at various domestic purpose. They also find numerous application industry, such as food process, or pharmaceutical, agro industry. We can use it, and solar dryer also more economical compared to the dryer that run on the conventional fuel or electricity. The drying process is completed in the most hygienic and eco-friendly. Solar drying system have a low operation maintenance cost. Solar dryer at least longer, and a typical dryer at least can 15 to 20 years we can use it. with many minimum. So there are three kind of solar dryer: integrated solar dryer, distributed solar dryer, and mixed mode solar dryer. Integrated solar dryer is one which a solar energy collection and drying that take place in a single unit. And the cabinet dryer, rake dryer, and tunnel dryer, greenhouse dryer, and multi-rake dryer fall under this category. Normally, these dryer are small size and stand alone unit. And distributed solar dryer, a solar dryer in which solar energy collected drying take place in separate unit is unknown as a distributed solar dryer. This type of solar dryer has two parts: one flat plate air heater, and second drying chamber. Air is heated in flat plate heater placed on the roof of the building or on the ground. Hot air from the air heater circulated in the drying chamber with the help of blower. This dryer can design in different sizes with various configuration depending upon the temperature of hot air, airflow rate, and type of production to be dried, etc. Mixed mode solar dryer is solar dryer in which solar energy take place on both air heater and drying unit, and drying take place only in the drying unit is non-mixed solar dryer. In this dryer, solar energy is collected through flat solar collector and also by roof of a drying chamber. In a large industry drying system, the solar heated air is combined with air heated conventional energy. This adds to the reliability of the system and at the same time help to significant reducing conventional energy consumption. This is the solar drying process in Thailand. Thailand actually using solar dryer from long time ago because they have many natural like banana, pineapple, and durian is the most famous, and also mango. So they're using.
We've been exploring 2 Thai provinces off the beaten tourist track, and we've seen some amazing sights. Before we review the highlights, we've got one more sight to see.
What are you looking for? Smooth texture, rich color, flawless skin, perfect proportions, full body? I came to Phitsanulok in northern Thailand in search of a perfect, ripe, succulent, sun-dried banana.
This area of Phitsanulok is blessed with bountiful banana trees, and they have seeded a cottage industry. Plenty of people still sun-dry bananas in their backyards, but here the industry has moved from the cottage to a factory, quaintly called the Banana Society.
Run gluai gluai, it means it's a banana story, a way of saying it's a no-brainer. But actually, sun-drying a banana is an exact science. These parabola domes carefully calibrate temperature and humidity. They are building the bigger, better sun-dried banana.
So exactly what is happening inside the biodome? Not much. Bananas are drying. A lot of bananas are drying. And when they're perfectly dry, they move into the more exciting part of the production process.
There are some serious carbohydrates being burned here. In this factory right now, 3,000 kilos of raw fruit are being processed into 750 kilos of solar dried bananas. And I think I had better play quality control inspector. I wasn't allowed to eat it in there because of health regulations, but now I can tell you, this solar dried chocolate dipped banana is Aloy.
Yum yum. Now it's time to look back at some of our adventures here in Phitsanulok and Phetchabun. It's just a 1-hour Nok Air flight away from Bangkok, Phitsanulok, and the neighbouring province of Phetchabun, Thailand, on the Tanon less travelled.
That was nice.
Thank you, sir. Now we'll discuss about solar rooftop, because we know that solar photovoltaic energy is how much actually, what is the market share in future. So we can see that global solar rooftop photovoltaic installed market or value 29,770 million US dollar in end of 2016, and it's expected that it will be increased 64,671 million by 2023. So we can see that it's a huge improvement. Huge increase and also the cover the market, because we know that solar energy even have some research gap or some of lacking disadvantage, but we may replace it like solar thermal, where solar photovoltaic is not convenient, so we can use solar thermal if and also we can use the solar dryer, solar air cooling. There are many things. And also we can see that it will be the registration of CAGR from 11.2% from 2017, and it would be increased 2030. And rooftop solar photovoltaic installation as an electrical sources converted into, we know that it will convert the electricity. And in the recent years, solar photovoltaic rooftop has emerged and potential green technology, and also combat climatic change by reducing the dependency on conventional fossil fuel based energy. Rooftop solar photovoltaic system are distributed power generation system and help to building energy needed provided the electricity. So we know the benefit of a solar rooftop. So this is, and we will see that this is the actually in future, is it possible to run industry by using solar energy? This is the great example for us. We know that Huawei technology, Huawei industry, they are developing technology there. So they already divert to renewable energy. They use their sources, solar panels. So we can watch this video also, how they are.
Hello. With the world's energy needs only set to grow, it's incumbent on every individual, every government, and every industry to think about the energy we use and the energy we generate. To put it simply, solar is going to become one of the world's most important energy sources, perhaps even the most important.
You're absolutely right, Colin. Hi, I'm Jacob, and we're about to take you on a quick tour of Huawei's Smart PV demonstration site here in the city of Dongguan, South China, not far from the company's headquarters.
Most people know Huawei as a smartphone and telecoms equipment manufacturer. Not many people know that the company is also active in the photovoltaics industry and has been for some time. Photovoltaics, PV for short, is all about converting sunlight into electricity, of course. One of the key advantages Huawei brings to PV products is that it can integrate the really innovative information and communications technology that it's known for, technology like artificial intelligence, bringing huge added value for individual customers and corporations alike. We're speaking to you in the first quarter of 2021. Now, obviously, given what's going on in the world right now, you can't pay an in-person visit to this demonstration site.
So Colin and I are going to take you on a quick guided tour to see some of the highlights. Let's check it out.
Within 2 years of entering the solar power industry back in 2015, Huawei quickly established itself as a serious player, and that's testimony to the company's approach.
When crafting industry solutions, Huawei works hard to see things from the customer's perspective. How, for example, can Huawei help reduce pain points over a PV plant's typical 25-year life cycle?
The answer lies in making simple, digital and automatic operations and maintenance, or O&M, a reality. On this rooftop, we've simulated 3 scenarios where solar panels are typically used: on rooftops in residential areas, where you might power your own home, in commercial and industrial settings, including shops and factories, and finally, large-scale use in the utility sector.
Let's take a closer look at some of Huawei's innovations.
Now, the total capacity of all of the solar panels at this plant is 17.5 megawatts, and all of this gear is capable of generating 17 million kilowatt hours of electricity per year. Moving on, you can see that the ground here is half covered in artificial grass. The other half is concrete.
What you can see here is a simulation, where strings of Huawei's bifacial module and tracking system solution are working under different operating conditions.
Generally speaking, Huawei Fusion Solar Solution makes use of something called multi-maximum power point tracking and a smart direct current system to achieve 1.5% higher yields.
This is the residential scenario and what a rooftop of a house might look like. When we simulate a shadow that obstructs light, notice how this optimizer resolves shading problems, ultimately helping to achieve up to 30% higher yields. That's the benefit of a full optimizer solution.
That's exactly right, and with this kind of optimizer technology, we can all save on our home electricity bills. And for many of us, those bills have skyrocketed over the last 12 months as we work from home. And Huawei also offers a battery storage system, giving families access to renewable energy around the clock, day or night.
Moving over to this cabinet, and we've got another simulation running.
That's right, and in this simulation, we're running under an uncomfortable, high-temperature environment. Essentially, Huawei prioritizes inverter reliability to ensure that plants can run smoothly and efficiently throughout their entire life cycle, and all of that starts at the very beginning, in the design stage. If you can hear the sound of running water, the equipment in this cabinet is running under a high-pressure water jet.
This environment simulates inverter operations during more extreme weather conditions, such as a heavy rainstorm.
There's a pretty obvious reason why there's so much emphasis on reliability, because the higher an inverter's availability, the lower the amount of yield losses caused by inverter faults, and that means better yields overall for PV plants.
Now let's head over to the Fusion Solar Smart PV O&M Center to see how the solutions are centrally managed.
We're standing in the Fusion Solar Smart PV O&M Center. Let's see how it works. Visualized on the screen, we can see an overview of the whole power plant. And with this kind of visualization, only 2 members of staff are needed to take care of this whole power plant, around the clock, managing everything from this operations center.
This is all made possible thanks to the Fusion Solar Cloud Management Platform, which connects with and manages solar plants all over the world. We can see real-time, high-resolution video of the power plant from a range of angles and orientations, ensuring that we always have visibility of the full picture.
Exactly. A network of cameras allows us to examine individual parts of the plant remotely. If something goes wrong on site, we simply perform a remote check, quickly and easily diagnose the problem, then send someone to fix it, armed with the knowledge of exactly what it is they have to do.
Let's explore how that works.
Huawei can provide its customers with a unique intelligent IV curve diagnosis function enabled with a single click of the mouse, like that. The function automatically detects the voltage and current of PV strings and generates an IV curve, short for current voltage characteristic curve. The system then uses AI to compare this IV curve with a comprehensive database, allowing it to detect and report on the running status of PV modules across an entire PV plant.
And while traditional plant O&M requires tedious manual on-site spot inspections, which can take several months to perform, this smart IV function can inspect 100 megawatts worth of equipment in mere minutes. For an entire PV plant, a complete diagnosis might even take only 15 minutes.
AI-powered intelligent IV diagnosis like this is completely transforming how routine inspections are conducted, doing away with the need for those traditional manual techniques. It's capable of performing inspection of PV modules, automatically outputting full reports, and accurately identifying 14 categories of failures. And with AI machine learning, accumulated IV experience only improves the failure model over time as it conducts self-analysis and learns performatively on the job, meaning that it gets better and better at what it does.
The smart IV diagnosis technology, jointly developed by Huawei and Huanghe Hydropower, has been used in the industry since 2014 and has already been applied around the world in 7 gigawatt power plants and even higher.
For example, for a project in the city of Guamu in China's northwestern Qinghai province, complete diagnosis of a 100 megawatt PV plant takes just 15 minutes, representing cost savings of a sizable $1.5 million over a 25-year time span.
Elsewhere, at a 50 megawatt PV power station located in a mountainous area of Datong, a city in northern China's Shanxi province, manual O&M has traditionally been arduous given the challenging terrain. Now, O&M staff at this site have been empowered with Huawei's intelligent IV diagnosis tool, which makes site maintenance far easier and therefore far more efficient, since it can be handled remotely.
These are just some of the interesting innovations that Huawei has made in the solar energy field, with many more to come.
Thank you very much for the time that you've spent with us today.
And if you'd like to learn more about Huawei's smart PV solutions and products or explore their real-world applications, please search Huawei Fusion Solar or contact your local sales representative.
All right, how about we wrap things up there? See you next time.
The market growth is boosted by demand for the solar power in the emerging market of all constant, especially in area where electricity is needed the most and moreover rapid expansion of the market due to the increase of competitive of solar photovoltaic rise the government initiative and also the private company, and they can we can demand the electricity. We can see that solar market technology. We can see that this is the 2030 predict that this technology, and we can see that how it work, residential and non-residential, how is it work. And this is the overall Thailand scenario. Last two sessions I discussed about the solar photovoltaic and also solar recycling, and some of video I showed the condition of Thailand. But this is the overall situation in Thailand and one documentary. So I believe you will enjoy and you may have idea about Thailand, how they are working about the solar photovoltaic technology.
So here I am at one Chai shop, the one in Turn and I thought I'd show you around. Just going to meet up with them, and then we're going to go into Tang Kong to show you the solar farm system up there that he's just installed. But I want to show you here at his shop. He's actually got a shop on solar. So that's the system there. You haven't got the meter on. So basically what it does, if he gets a power out, then the solar cell takes over, you know. Which is quite happens quite often in Thailand, you know. He's also got street lights here. Different types of lighting. For your tops of your walls, your garden walls. Yeah, these are quite handy. I mean, they're only 189 baht, very cheap. Yeah, these are the ones I like to use. That's why I put in pies. And there's all these ones here. So he has a good selection of equipment, electrical and other things, you know. So anyway, I'm gonna go and see him now. There he is. There's the man himself.
สวัสดีครับวันชัยการไฟฟ้าครับ
That's it. So what I'm going to do, guys, I'm going to put the drone up outside the shop here so you can actually get a good view of the shop and the advertisements. You'll actually see the solar cell on the top here. So and then after that, then we're going to go on to the other place. Alright, okay, I'll catch you in a bit. So in here you've got lithium ion batteries, and these are gel batteries. So these are 160 amp batteries, 6 volt, so they're paired up all the way along. Then you've got your 12 volt batteries here, gel batteries, solar inverter, control breaker, and this is an energy storage inverter. I'm going to show you. Have a like. So we're just going to open this up and show you. Okay, now we've got the door open, and these are lithium ion.
Lithium ion.
Okay, so these are lithium ion batteries for the solar cell. So they're built in computer controller. And you've got like a fan here that's refrigerated. It's very cold. Wow.
แบตเตอรี่ในห้องเนี้ยทั้งหมดเนี่ยเหลือแค่นี้
So, okay, นี่ so กี่วัตต์กี่อัมป์ใช่ไหมนี่100ปี 1 2 3 4 5 so this system นี่12 kilowatt. Yeah, so this is system that we've got here for this temple is 12 kilowatt. So this is how many batteries you need, and then we've got the backup on here as well. It's very high tech. Yeah, wow. Can you up? Okay. It's like a fridge. This unit here is like auto lock, you mind? No. Oh. What? Okay. Okay. So this is a safety inverter. Sorry. So you got one there and one here. Shall I? Need backup. Is this like a backup? Because you got two inverters.
Jump start battery.
Jump start. Yeah, okay. So that's a jump start for the battery. Okay. And this for by connection, right? So this is all the breakers for all the different buildings.
แบตเตอรี่ในการตั้งค่าอย่าให้ใช้พลังงานลดต่ำลงเกิน 20%
Okay. So when the power drops down like 20%, this so it does a slow start and slow turn off. If the power goes too low or if it goes too high, then that unit there actually controls
ถ้า
that.
ใช้ไฟหมดเลยแบตเตอรี่จะไม่ทน
Yeah. So, Elena?
Have to lift battery.
Have
No,
to find more than-
not low more than 20.
Yeah, no,
If
20%.
low more than 20, battery kena
กลัวไม่ทนเสีย
no good and maybe kena not can use for long time.
Right, okay. So this just controls the battery level. Yeah, okay. Okay, fine. Battery breaker, combine them. You've got your other breaker units and so อันนี้6 volt อันนี้12 volt ใช่ไหม so you got 12 volt 6 volt and then you got your 12 volt in series. Yeah, all the batteries are in series. Okay, so I'm going to take you outside and show you the panels. By the way, one guy here, the same that installed for Pi, he donates all his time here for free. You know, so all what you're going to see today, he's installed for free for the temple. You know, so he called like Tambun. You know, so he gives for making him feel good inside. You know, he's an amazing guy. He took me and Pi for dinner last night, and it was for breakfast this morning before we actually come here. So I'm so pleased to be here and meet the monks. You know, I'll tell you a little bit about the area once I've showed you around on the solar farm here. So as you can see here, we actually got some panels ready to be installed. These are any Samloy C-SIP watt. Samloy Sam. Okay, 330 watt panels. There's quite a few here. So we'll come over here. And as you can see, he's got quite a few panels here already. So there's a set there and a set here. I'll just go up these stairs. I don't know if they can hold my weight. Oh, Nicoa. Die. So what we got there, 1, 2, 4, 6, 8, 10, 12, 14, 16, 18. So there's 18 on here, 18 on there. And so it's 36 on there. That's a lot of solar panels, and they extend more. They've got some new buildings going up. The only light they had here was by candles, and now with the help of Shera company, Skylink solar company, they've donated the panels. Shera's donated all the materials for building, free, you know, to this project. And one time him and his team donated the time for installation, and what an amazing setup, you know. So I'm going to put some stuff up and you can see how the layout is for here. Okay. So like I say, 3 years ago everything was lit by candle, and then they started using some solar cells over on the building over there. I'll show you that in a moment, which were just a few little panels. And there was one guy that stayed here as a monk, reached out to Shera and the Scat. If you want to, some of the local building companies donate the steel, you know. Yeah, even the Shera roofing, same what I've used on the Shanghai project. Yeah. Wow, there's pathways going all over the place. So there's some long trails through. I'm saying other people can come and visit here, yeah. I'm and stay if they need to stay, if they want to feel the experience of what it's like to stay in a monastery, you know. Wow, amazing, isn't it? But it just goes to show how good people are donating their time, you know. I mean, I didn't know how much once I actually donated. Okay guys, thank you for watching, and so
SPCG Public Company Limited is the biggest company in Thailand. They are the biggest investor for solar rooftop industry. They have many projects, and in Thailand they are dominating the solar rooftop industries. Like their also motto is like strive to be to become the leader in renewable energy in Thailand. So they actually promote solar energy in Thailand now, day by day, grow up dramatically every day. So this is now I'm going to show you the SPG project, how they installed in one industry, and they are using this solar energy. Sorry for that. Maybe they use Thai language, so you may read subtitle. You can see the subtitle English. So
พาท่านผู้ชมมาดูการใช้พลังงานอย่างสมาร์ทที่บริษัท J-Tecto Thailand จำกัดซึ่งเป็นบริษัทในกลุ่มของโตโยต้าท่านผู้ชมคะ J-Tecto เขาผลิตและจำหน่ายชิ้นส่วนยานยนต์นะคะอย่างนี้ก็เป็นชุดบังคับเลี้ยวรถยนต์นะคะและที่สำคัญนะคะสินค้าเหล่านี้ผลิตด้วยพลังงานสะอาดก็คือโซลาร์รูฟท็อปบนหลังคานะคะจึงมีส่วนสำคัญในการช่วยลดภาวะโลกร้อนค่ะที่นี่ติดตั้งโซลาร์รูฟท็อปเกือบ4เมกะวัตต์ค่ะสามารถผลิตกระแสไฟฟ้าได้เกือบ6ล้านหน่วยต่อปีมาคุยกับผู้บริหารกันค่ะคุณสมพงษ์คะในรถยนต์1คันเนี่ย J-Tecto ทำอะไรบ้างคะ
เราได้ผลิตตัวชุดระบบบังคับเลี้ยวของรถยนต์ตั้งแต่คอพวงมาลัยจนกระทั่งมาถึงเปลาขับหน้ารถยนต์เลยครับ
ทั้งรถกระบะรถเก๋งด้วย
ใช่ครับ
กี่แบรนด์คะที่ใช้ของเรา
เกือบจะทุกค่ายรถยนต์ที่อยู่ในเมืองไทยนอกจากนี้เรายังทำพวกตลับลูกปืนที่ใช้ในรถยนต์
และท่านผู้ชมคะชิ้นส่วนรถยนต์เหล่านี้นะคะมีส่วนช่วยลดภาวะโลกร้อนได้นะคะเพราะว่าผลิตจากพลังงานสะอาดก็คือโซลาร์รูฟท็อปนั่นเองแนวคิดของ J-Tecto ในการใช้โซลาร์รูฟท็อปนี่คืออะไรคะ
วิสัยทัศน์ของประธานมิสเตอร์คอนโดซึ่งเป็นประธานบริษัทของ J-Tecto Thailand เขามีความต้องการที่จะให้บริษัท J-Tecto Thailand เนี่ยเป็นบริษัทชั้นนำในเมืองไทยที่ดำเนินธุรกิจอย่างยั่งยืนถาวรและคงไว้ซึ่งสิ่งแวดล้อมควบคู่ไปกับการพัฒนาสังคม
นี่คือที่มาของการใช้พลังงานสะอาด
มันก็นำมาซึ่งนโยบายทางด้านการจัดการท่านประธานมีนโยบายในการที่จะลดผลกระทบเชิงลบช่วยลดภาวะของก๊าซเรือนกระจก
เป็นแนวคิดที่ดีเลยนะ
ครั
คะ
บ
ที่นี่ติดตั้งโซลาร์รูฟท็อปบนหลังคานี่กี่เมกะวัตต์คะ
3.9 เมกะวัตต์ครับ
ค่ะ
ซึ่งสามารถจะผลิตปริมาณกระแสไฟฟ้าได้ 6.2 ล้านหน่วยต่อปี เทียบเท่ากับปริมาณใช้ไฟฟ้าที่ใช้ในครัวเรือนประมาณ 1,300 ครัวเรือน
ยอดขายของเจเทคโตเนี่ยปีหนึ่งเท่าไหร่คะ
เรามีอยู่ 2 โรงงานก็คือที่บางปะกง ซึ่งเป็นโรงงานแห่งแรก
ค่ะ
แล้วก็ที่เกตเวย์ซึ่งเป็นโรงงานแห่งที่
ค่ะ
2 รวมยอดขายทั้ง 2 โรงงาน 15,000 ล้านบาทต่อปี
ซึ่งในยอดขาย 15,000 ล้านบาทนั้น ส่วนหนึ่งก็ผลิตมาจากพลังงานสะอาดนั่นเอง
ใช่ครับ
เท่ากับเป็นสินค้าที่เป็นมิตรต่อสิ่งแวดล้อม เจเทคโตจะมีการขยายผลเรื่องนี้อย่างไรบ้างคะ
หลังจากที่เราประเมินการใช้ไฟฟ้าที่โรงงานแห่งนี้แล้วเนี่ยนะฮะคาดว่าในอนาคตเนี่ยเราจะขยายผลจากโรงงานที่นี่ไปยังโรงงานใหม่ที่เกตเวย์แล้วก็เรายังมีแผนในอนาคตต่อไปที่จะขยายไปในเครือข่ายที่เป็นซัพพลายเออร์ของเรา
ณขณะนี้นะคะมีแสงแดดโซลาร์รูฟท็อปกำลังผลิตกระแสไฟฟ้าเดี๋ยวเราไปดูกันว่าผลิตได้มากน้อยแค่ไหนค่ะ เห็นเป็นกราฟแท่งสีส้มๆนี้คือการใช้ไฟฟ้าในโรงงานที่มาจากโซลาร์รูฟท็อปนะคะกราฟนี้บอกอะไรบ้างคะ
กราฟนี้นะครับจะแสดงให้เห็นถึงการใช้พลังงานจากโซลาร์รูฟนะครับซึ่งจะเป็นแท่งสีส้ม เราจะเห็นได้ว่าตั้งแต่ 6 โมงเช้าเนี่ยเราเริ่มทำการผลิตไฟแล้วช่วง 11 โมงเนี่ยแสงแดดค่อนข้างที่จะแรง เราสามารถใช้พลังงานจากโซลาร์ถึงเกือบ 70%
วันนี้เราใช้ไฟฟ้าจากพลังงานแสงอาทิตย์เกือบ 22%
ตั้งแต่เราติดตั้งมานะครับตอนนี้เราสามารถผลิตกระแสไฟได้ทั้งหมด3ล้าน1แสนหน่วยนะครับเราค่อยๆทยอยทำการติดตั้ง
จนล่าสุดนี่ก็คือ 3.9 เมกะวัตต์นะคะ
ใช่ครับ
ประหยัดเงินไปเท่าไหร่แล้วคะ
เราสามารถประหยัดเงินไปได้เกือบ 13 ล้านบาทแล้วนะครับสามารถลด CO2 ได้ทั้งหมด1ล้าน7แสนกิโลกรัมนะครับ
นี่คือช่วง1 ปีที่ผ่านมานะคะหลักการทำงานเป็นยังไงคะ
โซลาร์รูฟจะได้ไฟฟ้ากระแสตรงจะส่งผ่านตู้อินเวอร์เตอร์เพื่อแปลงเป็นกระแสสลับ จากนั้นเราก็นำกระแสไฟที่ได้ไปใช้ในรายการผลิตครับ
เท่ากับว่าไฟฟ้าที่ผลิตได้เนี่ยจะใช้ในรายการผลิตก่อนและถ้าไม่พอก็ใช้ไฟจากการไฟฟ้า
ใช่ครับ
ข้อดีของการใช้ไฟจากโซลาร์รูฟท็อปนี่คืออะไรบ้างคะ
เป็นพลังงานที่สะอาด เราสามารถช่วยลดโลกร้อน ช่วยลดการปล่อยก๊าซ CO2 และเรายังสามารถประหยัดค่าไฟได้ถึงปีละเกือบ 23 ล้านบาท
การคืนทุนเป็นยังไงคะ
เราได้สิทธิประโยชน์จากทาง BOI ทำให้โครงการโซลาร์รูฟของเราเนี่ยสามารถคืนทุนได้ในระยะเวลาเพียง 4 ปีกับ 4 เดือนเท่านั้นครับ
โซลาร์รูฟท็อปในประเทศไทยเนี่ยก็จะมีผู้ประกอบการหลากหลายประเทศเข้ามา เจเทคโตมีวิธีการเลือกผู้ประกอบการที่มาให้บริการอย่างไรคะ
สำหรับระบบโซลาร์รูฟเนี่ยมันเป็นระบบที่อายุการใช้งานยาวกว่า 25 ปี เพราะฉะนั้นเราจะต้องเลือกบริษัทที่มีประสบการณ์ แล้วก็มีบริการหลังการขายที่ดี
คือทั้งตัวคุณภาพของแผงโซลาร์เซลล์เองก็ต้องมีคุณภาพสูง แล้วก็รวมไปถึงผู้ให้บริการที่มีความมั่นคง
ทางเราได้เลือกบริษัทเคียวเซล่าแล้วก็บริษัท SPR ครับซึ่งเขามีความชำนาญทางด้านการติดตั้งระบบโซลาร์รูฟนะครับระดับโลก
ท่านผู้ชมคะนี่คือตัวอย่างของการใช้พลังงานอย่างสมาร์ทที่เราพามาชมกันนะครับ
Thank you so much for your attention. Now, floor is open for your comments. Thank you so much, sir. Hello.
Yes, sir, we here. Thanks for your presentation. It was a very informative presentation.
Thank you, sir.
Hello, sir. Good morning from here.
Yeah, good morning.
This is Emeline. Thank you so much for that video. I've learned a lot, especially those being acquired by different countries. Earlier before, we have a conversation with my colleague here in the Philippines, Miss Arlene, because I appreciate the one that you have shown, the solar dryer used for banana in Thailand.
Yes.
It was very good, and I think it's already an industrial scale there in Thailand. We have a similar dryer that we use here in the Philippines. I'm not yet ready to show it, but I hope I could show it later today or by tomorrow. We have a what we call multi-crop solar dryer. It's
Okay.
a multi-crop, so it can also be used for root crops. It can also be used for fish. So the
Yeah.
one that we yes, sir. The one that we use here is drying for fish because our province is known for rich marine resources. So we process this marine resources in our location, and there is a fish drying industry that is booming here now. So we are also promoting the use of solar dryers instead of mechanical dryers. So for the information of everyone, this is a technology intervention offered by the Department of Science and Technology. Again, where I am connected with now, we are offering this technology in different communities, and it's very helpful, especially that I have noticed that for the energy sources, I mean, different uh, plants or a facility that the developed nations are having are really cost expensive. We understand that, and that's why I can see that our assistance in this technology for providing communities with this just a smaller scale, wherein we can use renewable source of energy for different activities in the community, can be a very feasible one, because since we don't have much financing yet to have a bigger scale to really tap on these renewable energy sources. So I think it would be a very good help to start with smaller communities, have a smaller scale of like this one, solar dryers, and be replicated in different communities, so as also to show that really we are promoting this type of tapping on a cleaner and renewable energy sources. So that's, I think, uh, what we can do for now, since we know it really requires big financing for a bigger scale of projects like that that you have shown.
Yeah, they're promoting also the tourism because of those area tourism based as so tourist based.
Yes, sir. Yes, sir.
Yeah, they use the combine like their traditional foods, so they can sell it, and it can help also develop the economy. Yeah, thank you so much, Emily.
Yes, yes,
I
definitely,
can see
yes.
that Michael would like to say. Michael.
I'm right here, sir.
Yes, sir. You raise your hand.
Pardon me?
You raise your hand.
Oh, no, I did not. But what I would contribute towards the presentation, uh it's interesting that we are now actually utilizing what was actually there for us for forever, like our natural, I would call it the natural battery, like our solar sun. The sun is a natural battery. All we got to know is how to harness the energy from the sun and utilize it. And now we're actually going down in that path, and we're finding different ways and different technology to utilize that. At this point in time, global warming is not like I would always say, it's not an isolated event. It's a it's the world event. There's no way that we can take a part of the world and say, well, all right, it's not going to affect us if we practice this. Even with Guyana, we are lucky because we have our like 87% of our country has pristine forests. So we contribute in terms of absorbing the carbon. But that doesn't say because we do that, if the effect of global warming will not affect us. So therefore, it has to take an holistic approach in terms of dealing with this. And the soul, for me, when I'm looking at these presentations, how far you guys are advanced with solar technology, clean coal technology and stuff, and we're still holding on to the fact that we have this pristine forest. I think we're way behind, and it shows that there's a lot of work for us to do to get up to speed of getting into utilization, adapting to sustainable energy sources. And that's what I will say for me. That's my contribution.
Thank you, sir. Thank you, sir. Yeah, you are right. If in your country, for example, maybe solar thermal is not convenient or economy friendly for your country, but we may use solar photovoltaic. We just switch the technology, then we can actually stop our climate change. Christian.
Before you go, sir, we already started adapting to solar rooftops. I don't know if you remember in our presentation where we showed that the government has started to equip government buildings with solar rooftop. So we are adapting, but I'm saying, for me, I don't think we're adapting as fast as we should with what's happening with the world.
Yes, sir. Yes, sir. Yes, sir. Thank you, sir. Christine.
Hi, everyone. Thank you, sir, for the presentations. And I endorse everything that Michael said in terms of, our capacity to use solar to, I think now we're barely scratching the surface. And honestly, prior to this presentation, whenever I think of solar energy, I would always think of the panels. But from the presentation here, I was able to learn about like the power tunnel, the solar power tower, the solar dish, the cooling, and then the dryer. What I know that in Guyana, in the indigenous area, they actually do a lot of drying of fruits, like tomatoes and mangoes and so forth. But I don't think it's up to the scale that was shown in the video, whereby there's a solar dryer. I think they actually use and harness like the sun directly. So I think like I wish that in the next few years, like we can actually make use of the various like solar power technologies that we have. Like it's not only the panels. And one thing when I was listening to the presentation, what I was thinking is when we were talking about solar panels in the last week's presentation, we talked about the waste, the amount of waste is generated. So I was curious to know if you can tell me a bit about these other options, like what is the waste material generated? Is it similar to the panels where there is a lot of waste and it's not really recyclable or usable after, or are these more or less like producing less waste?
From solar photovoltaic waste, actually that one from solar PV, so we can recycle it. Actually, we already find out the solution in this 21st century. We already decided, maybe it's just started. And if, for example, if we use solar photovoltaic panel, so we can recycle it. We say when it becomes a waste, we know that if we may not recycle, so it's not good for our environment. So if we recycle it, it can help save our materials, resources, and also reduce the cost. So that can help. And at the same time, solar thermal, it depends on the solar thermal. We cannot set up all over the world, because of solar thermal need huge temperature like radiation. So those area actually use radiation. So we can use solar thermal, because for the boiling or boiler, we need to at least 200 to 500 or 600 degree. So we can use it. For example, we can use like desert in Arabic countries or Africa, some African countries, we can use it. At the same time, those countries depends on the marine, like fisheries, so they may use the solar dryer, because we can use it open space, but it's not actually hygienic sometime. So if we do the proper way, and it would be industrial. So everything we can, those earlier mentioned Michael, we need to take initiative, we need to set up our mind, so that can help us to stop our climate change. When we reduce temperature, so that time we may not need more electricity for cooling system. And even if we need cooling system, if we use the solar cooling system, that can help also. So there, yeah, technologies coming every day, day by day. So we need to promote it, and we need to promote our society, so that can help. Yeah, thank you, Christine. And
Sir,
anyone?
if I may, please.
Yes, sir.
Go ahead.
Yes, sir.
Yeah. Like I listened to what you're saying, and that is the interesting thing about renewable energy or sustainable energy, because there's no one fit for all. Everybody can have a different have a different approach to or different use of sustainable energy. Like you said, the terminal, not everybody, not all location can utilize it, or not all countries can utilize it. Therefore, there are other things. We can have the wind energy. Some countries can utilize the hydro plants and stuff. But what's important is that we all need to get on board with it, and find some form of sustainable energy which will be which can be useful to our country in terms of generating electricity to reduce the carbon emission. So, like you said, there's a variety of technology. We just need to get on board with the right one for your country.
Yes, sir. And also in future, my imagination, I can say that in future, maybe electricity generation will be centralized, not only one country, it would be maybe 3 or 4 countries together, and they may produce, they may distribute from one center to different countries. It will be future, because now for sustainable development, we connect each other, right? So in future it will be, because AI already came, so AI help us to develop our future technology also. Thank you, sir. Anyone? Jara?
One other thing I noticed from the presentation, you were showing us the statistics of countries that are using solar thermal energy. And
Yes.
one of it that stood out to me was United Arabs.
Yeah.
Because they're known for like oil, right?
Yeah.
But yet here they are like making use of this technology, and I found that really interesting that they're able to diversify their energy systems like way ahead of time, because we know that they're very wealthy in terms of like using fossil fuels, but here they are also investing in this technology because they probably see the importance of it as a sustainable option.
If, sir, you know why? Because if they implement their renewable energy technology, they may sell it to us.
Yeah, which is smart, right? I wish we can do something like that. And also the technology company, like this technology company that they produce your phone, and this is now I'm learning that they're also investing in solar. Well, it makes sense.
Yeah. So in future they will do like that. Anyone?
I think I will be the one to give some comments. Again, this is Anna. In the Philippines, we are thinking about the usage of this solar thermal, the CSP, the concentrated solar power. But we are looking at our place because we are composed of lots of islands. So I suppose this is maybe the last of the power source that we will be implementing, because you don't have that large space of arid deserts, and unlike in northern African countries where they have these deserts, so they can use that. So I suppose in our case, this would be the least or the last solar power sources that we can employ here in the Philippines. I think that's all.
Yeah, yes, sir. It's like for plant, it's need actually space, but a small scale, for small scale we can do that because of the solar thermal is not a expensive material. Maybe installment is a little bit expensive, but it's not too much if we compare it to solar photovoltaic. And just yeah, if we do in your country, maybe promote solar dryer and also solar thermal. It's like a small scale, not big scale, because in your country, if it doesn't have that kind of space, so you can use a smaller scale. Yeah.
Yes, sir.
March.
Yes, sir.
Please, some comments.
Yes, sir. Your presentation was an eye opener for me. For example, the CSP, I thought it was just a thing of the future, but really it is common and very well adapted in China. I don't know if China is, in your presentation, is the leading nation to harness the CSP, but I thought it was European nations who were the one who invented it. But now I can see that it is China who is the front runner in developing the CSP for adaptation to all nations around the world to address the global warming situation. And although it is a much advanced technology considering the situation here in the Philippines, but here in our country, the solar PV technology is the more prevalent one. You can see it in our homes, the street lights, commonly the street lights. I think the move from the conventional electricity to power our street lights, the move to change it into a solar energy has drastically improved our or decreased our carbon footprint as a nation. And I think this will be the thing of the future. I think this will be a key for us moving forward to attain and mitigate and adapt to the ever worsening climate situation or the global warming situation in the planet. For me, sir, I would like to also acknowledge my office, the DOST, for implementing projects that harnesses renewable sources of energy like the one Ma'am Emily discussed earlier about even yesterday, about the plastic densifiers and the solar dryers. These technologies developed by Filipino scientists is very ripe for commercialization and is actually in use in the provinces which have higher sunny days than most of the other parts of the country, because Philippines has 4 type of climate, and there are places where there is a very pronounced wet season, and there are places like us here in Zamboanga del Norte who doesn't have a very pronounced dry season. Rainy season is spread out equally in the whole year. So that are challenges that we will have to hurdle to have an efficient renewable energy supply. That's all, sir.
Thank you so much. Jara, are you available? Jara? Jara. Markelo, Mr. Markelo.
Yes, sir.
Hi, everyone.
Hello. sir. How are you, sir?
I'm fine. Thank you. So I just would like to give you some comments about your presentation. I think I mentioned before here in Ecuador we have problems with solar energy because we most basically use oil for energy production and also hydropower. So the percentage of solar energy is really low, extremely low compared with the other kind of energy. So I think the government nowadays is not really worried about the solar energy because they are investing in a new projects, big projects in using the hydropower because we have available these resources. But as far as I know, we have also some people that they are doing research about solar energy as well, because we have the potential, we have the people that studied this in abroad, and they know a lot about this kind of technologies. So I hope in the near future the government just start investing in these projects, and also with some political and economic incentives, some external companies or private companies can also do some investment in these projects also here in Ecuador. But that is something really interesting. Your presentation is really interesting to me because this is not actually my main area of research, but it's really interesting to me because I would like in the future to do some also related with these kind of technologies, because I think, and I know, as I mentioned before, we have a lot of potential here in related with solar energy. So that is from my side, sir.
Thank you, sir. Actually, for solar energy, you can in your country, if you need a dryer, so you may use. I know that we know you have hydropower, but concern is like earlier mentioned, Michael, that we may not waste our energy. So if for dryer, we can use solar dryer instead of even source from hydro. So that can also save our energy. So we can replace it, like it's like make a balance. So in future, I believe that you may promote, in future you may promote it if is there any possibility. Thank you, sir. Thank you so much. Jara, are you available? Mr. Julie.
Okay, sir. Good noon from the Philippines. So thank you very much. You have a very comprehensive presentation regarding the solar thermal panel in the country. As I told the other day, we started already using the solar panel, and then it is also an advantage because in some areas, for example, schools is very far from the connection lines of the electricity. So they were using the solar panel. For example, schools very far from the city, for example. So they were using solar panel actually, and then it is very helpful because in the school they were provided by electricity through the solar panel, and then they can operate, for example, presenting lessons through computer or smart TV, and then using appliances in the remote areas. So it's very advantageous actually. But the problem is the solar panel actually is so expensive, and then the available panel here in the country, especially coming from China, for example, it cannot sustain long. So that's the problem actually, because a solar panel is very expensive, and the government cannot provide all these things in the citizens, for example. So that's also a problem. But at present, for example, so I think this is the very good option to adopt this kind of technology because it can help mitigate our climate up for the climate change, for example. And I'm sure in the future, our government will adopt this kind of technology and we can help mitigate the emission of carbon dioxide that can contribute global warming globally as this a very global problem. Thank you.
Thank you, sir. We can make solar panel cheaper. Do you believe it, Christine, Michael, or anyone? We can make cheaper.
I think so. I think there's a lot of development and research that's already been done, and there's so many countries and examples out there of people actually doing it. I think though what's happening is like the fossil fuel industry is so ingrained in our society that it's really hard to make the switch over to really understand the impacts and allowing subsidies and so forth for solar. But I think even if we're thinking about the waste generated, I still think it's a better option, and I think it can be an affordable solution to this problem that we're facing.
Actually, how can it become cheaper? Because of if we look at our smartphone, 5 years before or 10 years before, user was not too much, right? So that time that was expensive. Now available user, that's why technology is cheaper. So solar module company, when they sell available or too much, the price will be reduced. And so people still now actually many countries, they are not taking initiative for buying or subsidiary solar panel. If they do, I believe that if we buy, then it would make it cheaper. If we not buy, it not make it cheaper. All the time it would become an expensive module. So it's dependent. So I believe that we'll promote it in future and we'll use it, even it's expensive. Then it would become cheap for future generation.
I agree with that. Yes.
Maybe, sir, if we can create our localized solar panel, maybe that is a very good move. So that this technology will become less expensive here in the country.
Yeah, yes, sir. No, I'm not talking about only your country. My country also same. They may not promote it because of that. This is the huge investment and subsidiary. It's not possible. You and I, it's not possible for us. But government first need to take initiative. If 10 countries and they took initiative for subsidiary, then company produce more module and it would become cheaper. So it's not one way communication, it's actually both way. So in future it will be, I believe that. Yeah.
Yes, sir. Maybe in the future it will become cheaper.
Yes, sir, of course. Because now iPhone became cheaper, right? But
yes, sir.
5 years ago.
Yes, sir.
But,
I agree with you.
But diversity, you can you imagine that like 100 years before, just few days I saw in on Facebook, say that 100 years before, rich men, they use a car. And general people, they use a horse. But current generation, general people use car, but rich men, they use horse. You see the changes.
Yes, sir. I totally agree with you.
This is the funny thing.
Yes, sir. And even in United Kingdom, their queen, they are using the horses.
Yeah.
Yes, for royal gathering. So even though we are in the contemporary world, but still other countries are still using the conventional means of transportation.
Yes. So all of you, do you know where I am from?
Where you're from?
Yeah, I'm asking you. Do you know that?
Yeah, you said Bangladesh last night, right?
Yeah, yes, sir. I'm from Bangladesh. I'm not originally Thai.
Yeah, I remember when we were talking about the food, you said that you can carry us to get both kinds of food.
Oh, yes, yes. Because today from today and day after tomorrow, our festival.
Oh, it's Eid.
Yeah, Eid, yes.
We actually celebrate that in Guyana too, but we celebrate it on Wednesday.
Okay, okay. But yeah, our one maybe same. So
Yeah.
you, Christian, your ancestor from India?
Yes. So
Yeah.
our country is a colonial country. We were ruled by the number of European power, but more so the British. So they brought over enslaved people from Africa, and then they brought over indentured servants. After slavery was abolished, they went to get indentured servants from India and China, and we have some Portuguese as well.
They look like us.
Yeah, yeah, exactly. Yeah. When I was in the US, a lot of persons would think they would never heard of Guyana, so they would just automatically think I'm from India.
And also when you join my first session, Michael, I was confused actually. I was confused. How could they are same but different?
Yeah, I know we're very diverse country. We have like when you say you're a Guyanese person, that could mean anything because a Guyanese person could be a mixed person. It could be someone that looks like me, someone looks like Michael. Like we're all very diverse, and it kind of throws people off a bit because we're located in South America, which is is a Spanish continent, but we speak English, and then we're so diverse.
Yeah. And another technology maybe in future because you are near the ocean. So maybe in future because that technology also expensive. The tidal technology, tidal energy, wave energy. Do you have any idea, anyone?
I've only seen it on some videos shared around the internet about the tide, the power
Yeah.
of the tide converted into energy. It has a very big potential, sir, actually, because tide never ends. You know, the waves never ends, and there are places with constant huge waves that people can develop technologies that will harness that energy. So yes, I have seen it on videos, but haven't seen it actually working or in person.
Yeah, but tidal energy or wave energy they produce it's not too much because of technology is most expensive. In European countries they are using that one, and Korea, especially Korea, South Korea, um, they are using that technology. Maybe 20 gigawatt. They are producing electricity gigawatt. So in future, maybe Michael, in Guyana, it would be one renewable energy sources, or those are near ocean like Filipino. Filipino, I heard they had some proposal about that issue. Um, Maybe in future, Indonesia, yeah, in Thailand. Still now they didn't took any initiative, but they are thinking about that issue. So in future, when all like our fossil fuel will be vanished, then people will develop that energy, that resources. Yeah.
Yes, sir, that will be possibly happen. Maybe the natural resources will become deficit anymore. So maybe these things will become really possible in the future.
Yes, sir. Yes, sir. You are also Philippine, also dominating technology development, right? Many companies they have industry in Filipino, right, Julie?
Yes, sir. We have a lot.
Yeah. So in future, maybe you think about West, EU West, the big because of everyone discuss about that issue. Maybe they just want to skip it. They say that, okay, we'll recycle, but the recycling process is environment friendly or not. We have to think about that issue. So maybe in future, all of you Philippines leader, you can promote that issue also before
Yes, sir.
anyone.
Okay, sir. Actually, sir, we have a very good laws or ordinances regarding solid waste management program in the country. But the problem here is the implementation is very weak. So there is no punishment if you're caught by an authority. So that's why people are not obliged also to do their job. For example, in the community. So that's actually, sir, the problem. Actually, we have very good laws and very good ordinances, but the problem there is the implementation is not such strong.
Yes, sir. Yes, sir. I do agree about that issue because in our country also same. We have a strong policy, but no one take action.
Yes, sir. That's the problem actually.
We have a strong policy, but no action. We have law like if anyone smoke open place, 5,000. But not only smoke open place, we have a open place store shop for selling cigarette.
Yes, sir. The government just posted it through the tarpaulin, but there is no strict implementation. Certain authorities do not also do their job. So what will happen is same again and again. So there is no concrete solution actually.
Actually, sir, problem is that until we fail, it cannot be possible implement anything. Because of actually people, if this mindset, the positively, earlier mentioned Michael, then we can change everything. If we rely on others, for example, that is not my duty, or we say like that, we cannot do that. That is the big problem, people don't care. That is the big problem.
Oh,
So
yes, sir.
yes,
Yes, sir. Compared to US and some other countries, their implementation is very good. That's why they don't have enough problem about solid waste management, etc., because the enforcement of their law is very strong. And if you caught throwing anywhere, so you will be punished right away compared to other countries.
okay, sir. Thank you, sir. Today we have country report Mark, Mr. Mark, Miss Kia. Kia is available. May I know actually where are she from? Kia, yeah. Anyone knows about her?
Kia, sir.
Kia. Yes.
Yeah, she's from the Philippines too.
Oh, okay, okay. Julie.
Yes, sir. I am ready with my report.
Yeah, and Miss Camberly.
I am ready also.
Okay, sir. See you after 1 hour, and take your lunch, dinner, or breakfast. And this is the end of the session. I may not take any session, and maybe I will join only the country report session. So thank you so much for your attention, sir. And if there are any possibility to work with you guys, please email me anytime. I will respond as soon as possible. And I'm working on solar, and also I'm trying to implement the waste um, recycling method. And outside of my work, I love to do public speaking. And yeah, so that's it from my side, sir. Thank you so much. And see you.
Thank you, sir. Do you mind putting your email again in the chat? I think I copied it, but I just want to make sure. And your name, like your full name.
Okay, okay, sir. And this is my full name. You may find me on Facebook or LinkedIn ID, Twitter, everywhere.
Thank you so
Hello,
much.
You can
sir.
see me at PM, PSU.
Hello.
Yes, sir.
Yeah, sir. Kia is not yet in the room because we need the organizer to let her in.
Sorry, I couldn't understand. So what did you?
Sorry, Kia needs to get in the room, sir.
Okay. So today we have three.
Organizer.
Okay, we have three. Okay, so tomorrow we okay. Thank you, sir. See you after 1 hour.
Thank you.
Thank you very much.